And so it's my pleasure to introduce the CTO of Seldon, Clive Cox, to tell us a little bit more about the problem they're trying to solve and their approach to doing so. So are you there, Clive? Hello from Bristol Harbour.
Thanks, Nick. So I'm Clive, I'm CTO of Seldon, and we're going to be talking about KFServing today.
Technical
Um, so,
difficulties.
so in this talk, I'll be going through various sections. I'm going to give you Seldon's view of MLOps. We've got the introduction at the start to see how that compares with that. Then we'll be focusing on KFServing and what we're doing in that project, and then looking at some of the aspects also discussed.
Okay,
Once you've got your
no
model
worries.
into production, what are the post-deployment steps? And then look at summary, and then look at some aspects of our enterprise platform,
No
which we'll be
worries.
demoing
I guess I
in
can
our
come
separate
back
section.
in a bit.
So during this talk, there'll be a couple of polls, which will be appearing on your screen. I think we've got some interesting questions. It'd be good to get your feedback on. So one is how you're using inference in your company at present, if you are. So is it real time, is it streaming, or is it periodic batch jobs? It's good to see where the focus is on that. And the other thing is obviously serverless. So we're talking about serverless today in KFServing. And so we get to see how that focuses on your roadmap. Is it something you're using? Is it something you're interested in, or actually not? It'd be interesting to get feedback on that. And hopefully those will be coming up on the screen so you can actually do those polls. So I'll get into the talk. So I'm going to give my views of Seldon's view of MLOps and how it fits in. So this is sort of our inspiration from a few years back. I'm sure many of you have seen this paper. So this was a Google paper from 2015 on the technical debt in machine learning. So they were highlighting that people think they just need to write the ML code and they forget about the amount of code that needs to be written around it to actually manage your machine learning into production. These ties to these boxes were the amount of code inside Google that had the surrounding requirements for running machine learning in production. And Seldon, as was said by earlier in the talk, we're focused on deployment and monitoring. So we're focused on those boxes there, really serving infrastructure, monitoring, those aspects. And that's what we'll be discussing and focusing on our talk today. And also today, it's interesting about what we see happening. And we just certainly see people choosing best of breed to fit in these different boxes. It would be great if there's one platform that comes together that brings it all together into one. But I think there's various companies you'll be seeing in these talks today that are focusing on different areas of these boxes and how it ties into how it all ties together. So another aspect of what we see is, which has really been discussed already, is there's really two big stakeholders in MLOps. One is the data scientists, and they have very particular tools that they understand and they use. The tools mentioned there, the training tools and the other aspects, and they have a very particular skill set of mathematics, computer science, and domain expertise. Then on the other side, you've got the DevOps who have their own set of tools, especially in the Kubernetes realm, which we live on, and those aspects of those tools there, Prometheus and Elasticsearch and Argo. And there really is a divide. So the DevOps are a bit scared of what the machine learning guys are doing. They don't really understand there's quite a different application to their normal applications they're putting out. And the data scientists are obviously more focused just on getting their model, and then they want to push it out into production and let other people do that. So there's a divide there. And in the past, that has really meant that there's it's increased the time it's taken to actually get those machine learning models into production, or actually they just stay as POCs, and that's the real shame. And so what we're trying to do in here in Seldon is really help you to create that sort of ML engineer, as it were, that crosses that gap. The trouble is those guys who do exist, if you want to hire one for your company, are very expensive and almost like unicorns. And so really we're trying to do with the tools we do, and also the tools in the other companies you'll hear about today, to really help to bridge that gap to make MLOps easier to run in your company. So the key thing is you want to get to the great things you can do with AI and machine learning out there to make a difference to your company and make this whole process easier. So that's really one of our goals here at what we're doing at Seldon. The other thing is the whole thing to do with ethics and things related to that in AI. Obviously, there's a great discussion now in society as a whole on aspects of how AI is being used, from privacy, transparency, accountability, the security aspects, and whether this is a benefit to society or not, etc. Is it safe to use, etc. And there's a big push there, and we obviously need to take that seriously. And Seldon is many discussions at different levels of government and stuff in terms of advising on this. And then obviously there has begun to be some regulations in this area, so GDPR and other aspects of regulation in the States that needs to be taken into account in terms of this particular area. So we really do need tooling that's going to help companies to make sure they're following the regulation, showing they're putting out the AI models safely, and they can understand how those AI models are actually behaving. And at Seldon, we're trying to actually help in this area, definitely. But it's definitely an area that's going to be changing a lot in the years to come as AI becomes a larger part of society as a whole. So another area, if we get more into sort of the technical area, is if you're a data scientist, and this is really tying into what we're going to be talking about today. So you've got your models, you've written them in some toolkits, TensorFlow and PyTorch, and you just want to deploy them, basically scale them, update them on a compute cluster, which might have CPUs, GPUs, and TPUs. There's been a lot of advancements in the last five years or so that really helped data scientists do this. So first, you've obviously got the sort of container runtimes that come in, so you can package up all your requirements for your model into a container, obviously Docker, and then the things that come after Docker, you know, in this area to make it really easier to make it more reproducible in terms of how you're putting out your actual applications. And then obviously on top of that is Kubernetes, so allowing you to actually build up a whole cluster, a whole set of servers that are managing many microservices together to actually create your application. So not just single containers, but whole collections of containers which needs to be managed at scale with the correct security and scalability, etc. And Kubernetes is the leader in that field, and we build our software on top of Kubernetes, and we see most enterprises going towards Kubernetes for their solution for all applications, not just machine learning, in a way that allows you, obviously the key thing of Kubernetes is you can deploy it anywhere on the cloud, whether you want to choose Google or AWS or Azure, or actually on-prem, or actually move between the two. So that's one of the great gains. And then there's a lot of tooling that's built up on Kubernetes. So Istio, say for the service meshes, the network aspects you need to handle, security at that level, and the routing of your requests between services. And that's great. Tooling is being built up there. And then tooling such as Knative, which is the stack of KFServing that we'll be discussing today, actually builds upon so serverless aspects and how we can use that. But there's still a gap, basically. Because what you're going to have to do, if you then want, as a data scientist, want to use this great tooling that you've got, you're going to have to understand all those Kubernetes aspects that we talked about. So you have to create those model servers, you have to configure the endpoints in different APIs, you're going to have to manage different levels of deployments and services, manage the scaling, these terms here, HPAs, VPAs, to scale up your application on demand, handle the readiness and liveness probes, handle your actual model assets, handle the actual service meshes helped by Istio, but you're going to have to configure that yourselves, handle the asynchronous processing for the payloads, and handle your GPUs at runtime. So there's a lot of stuff you're going to have to do as a data scientist to manage that. And it's going to take a lot of skills to actually achieve that. So therefore, filling in that gap is the work we're trying to do. So we're building on the top of the great stuff that's come below in Kubernetes, Istio, Knative, then building on services that really focus on data scientists once they've got their model, putting it into production to actually serve requests. And that's what we do in our projects, Seldon Core and KFServing. So to focus on the projects we focused on at Seldon, and we'll be discussing a few of these today. So we've talked, there's a central layer, which is Seldon Core and KFServing. So Seldon Core is probably the most mature project. It's been around for several years in terms of providing a general abstraction for deploying your actual models onto Kubernetes. And KFServing is a more recent project we worked on more at the research level, but becoming more mature day by day in terms of actually using some of the more serverless aspects that are available on Kubernetes and building on that. Then we have the suite of products we call Alibi, which are based on the aspects you need to have when you've deployed your model. So when you've deployed your model, what are the things I need to know that it's running successfully? And how can I explain models? And how can I detect that the model is actually running correctly in terms of monitoring it? And we'll discuss that later in this presentation. And then the top layer is our enterprise stack that builds on this open core, because we're an open core company, so everyone can use the underlying stack, and we bring it together into our enterprise deploy product, which we'll be demoing in our separate session for those who wish to join after this talk, show you how you can use deploy to actually join all these technologies together. So diving straight into KFServing, which is the focus of this talk. There's various people in the industry from different companies who were working on MLOps. So we came together about a year or so ago to see how we could build on serverless aspects that were available in Kubernetes and really build a solution on top of that. We did it inside Kubeflow, which is a great ecosystem for various projects that are tied together to help you to do machine learning on Kubernetes. And KFServing is focused on the inference side. So once you've got your model, however it's built, it could be using other Kubeflow tools, or it could be using other things like MLflow or other aspects to actually build your model, how to push it out on Kubernetes and use the serverless aspects of Kubernetes to scale to 0 when there's no traffic coming to your model, and then scaling up on demand. And we'll describe some of the aspects of that and how we designed it in this talk. KFServing, so we provide a sort of general abstraction in terms of how you define your model. So it's a Kubernetes custom resource. So you define your YAML to describe that resource of what you want to put out into production, and then KFServing will manage the rest. So here we've got 3 examples of that custom resource YAML that you describe to push your model out. 3 versions of 3 different types of models, and you can see that it's quite a simple interface to get the basic model out into production and managed. So we've got one for scikit-learn at the top, one for a TensorFlow model in the middle, and one for PyTorch at the bottom there. And really all the person has to do is just provide the location of their model artifact that's been created in training. So here you've got like a Google storage location in both of those to describe the actual artifact. This could also be some other bucket location, or it could be a location on the actual Kubernetes cluster on some particular so NFS or PVC on the cluster. And that's all you have to do. And then we'll manage, we'll create the actual endpoints, we'll bring up your application in a serverless manner. And so when it receives requests, you'll scale up as needed. We'll handle all the other aspects of metrics and monitoring. So it's a very simple interface, and we'll go into further some of the more complexities of the interface if you want to build up some aspects. So if you wish to then update your model, so obviously you at some point you'll have a new version of your model, you can add a canary to it. And that's just a simple addition to the definition. So you simply add a canary section to the YAML and describe where that model is. And here we've added some other customizations which you can do. So if you have particular customizations in terms of what you want in terms of resources, CPUs, GPUs, or memory, you can add those in, and you can describe the scaling requirements of your model as well. So in this example here, we've said it should always have at least 3 replicas available of the model, and we don't want it to scale above 10. And we've also described the actual amount of traffic we want to push to the model. So here we want 25% to go to the canary, the model we're testing out here, the RS version 2, and we want the rest of the traffic to go to the main model. And so then we can test out our model, and then once we've happy with the model, we can just make it and push all the traffic to the model by changing this YAML and updating it to just the main model. And the key thing to understand here for those who are not most so knowledgeable of Kubernetes, it's all declarative. So this YAML can be stored in source control, and so therefore you can have every single version stored in a complete history of what you've been doing in terms of updating the model in the stages and the whole life cycle of the model. And that's great for auditing. So if DevOps or data scientists come on and they change any of these parameters, that can be committed to source control and then updated on your cluster, and you've got that full audit history and lineage of how you've been using the model. And that's obviously one of the advantages of the whole abstraction of Kubernetes, allowing you this sort of declarative representation of infrastructure, which is the key thing in Kubernetes. So another example here of going taking to the next stage is when you want to have things like explanations or transformations of your model. You can add that into KFServing simply as an extra addition to the YAML. So here we've added in the top one an explainer. So this is from our Alibi toolkit. So this is a particular model that we put out, a scikit-learn model, and we'll show this in the demo. And then we've added an explainer to this, a particular type of explainer called anchor tabular, which takes the tabular input of this particular model and gives explanations for it. So this will open up another endpoint that you can then, for particular predictions, send that input that you got your prediction back from, send the same input to the explainer, and it'll give a description of why the model was giving the particular output it did. Obviously, this is key for really understanding how your model is behaving, both in development and also in production. And then also, obviously, some models require further transformations, maybe before the model or after the model, and you can add those in KFServing by simply adding another component to your YAML. Here, we've at the example at the bottom, you've got a transformer, which is going to transform the raw image request here. This is like an image classification model, and it's going to transform it into the structure that the model needs for this actual PyTorch model. There's very simple extensions. So really what we're trying to get to here in KFServing is provide a very simple but slightly opinionated interface for the core things that we think cover the base requirements for deploying models. So that is allowing you to define a core model, a default endpoint that has transformations, or optional transformations and explainers, but with a core predictor. And then allowing you to add as needed a canary endpoint to when you want to update the model. So very simple, just core things that you need to do to get your model out in production with a very simple design that you can follow, and then we'll manage all the rest for you. So now I just want to go into some of the aspects that we're trying to solve also with KFServing that you might not realize at first glance. And that's the aspect of GPU autoscaling and why that's a challenge. So when you've got a model server, obviously, if you're using GPUs, you'll have you have the CPU connected to the actual core model server, but you'll also be using the GPU. And you might also have TPUs if you're using on Google Cloud. Now, each of those different components that you're using for your model server will be giving back metrics. So obviously the CPU usage and memory, and the GPU duty cycle and its memory, and maybe the TPU usage. And actually some of those metrics are quite hard or might not always be exposed, because your GPU metrics are quite laggy in terms of some of the Kubernetes actual implementations on different providers actually don't provide good access to GPU metrics. So what you're going to have to do if you've got a machine learning model that's using a GPU is then create an auto-scaling decision. So taking these particular metrics, how do I combine these metrics in a particular way, handcrafted way, to actually create a decision of when to scale up and also when to scale down? And it's actually quite hard to do to actually handcraft that. So you're going to find it very difficult to actually get the correct auto-scaling decision that works both ways, scaling up and scaling down as needed. So one of the advantages that we can take into account with KFServing, because it's built on Knative, is we can use the Knative solution to this as we're building on top of that stack. And basically, Knative, basically, all you have to do is, what it's looking at Knative is just the number of in-flight requests going to your model. So how many requests are in the process of being processed by your model? And all you need to specify as someone running your model is how many concurrent requests my model server can handle. Is it just a single one, or is it actually can handle multiple concurrent requests at the same time? And from that, we can Knative can use decisioning to decide whether to scale up or scale down. Basically, what it's going to be doing is basically Knative adds a kubeproxy component next to your model, a sort of sidecar, as it's called in the Kubernetes terminology, to understand the requests that are coming through to your model. And then understand how many are being processed. Then those requests can be understood by an auto-scaling component that's saying, okay, I'm seeing 3 requests here being pushed to the model, and actually it can handle only this number of requests concurrently. And from that, it can decide whether to scale up or scale down. You know, is there more resources, or is there not enough resources? And also Knative adds some extra components that are actually really great. Is that if there's a burst on the initial request when scale is actually 0, because we're in serverless mode here, it can actually hold those requests, actually buffer them until the actual pods come up. And then when the pods are up, it will then forward the requests. So when it's at 0 and you want to scale up for the first time, those requests will be buffered and then pushed onto your model as the pod is ready. And also, if you have a sudden burst increase of requests, then as the autoscaler will see, okay, there's a certain number of requests coming in, I've only got 1 pod, I need to scale up. There'll also be a slight lag, and that can be buffered and pushed there, so you can handle those quick bursts of requests. And the big advantage, going back to the problem, is that this really handles the GPU autoscaling. You don't need to worry about all those complex metrics. You just need to say how many concurrent requests my model server can handle, and Knative will handle it the best, will manage it, basically. So it gives a very clean solution to GPU autoscaling, which is what a lot of the latest models and getting the greatest scale out are actually using today. So in summary, KFServing really provides you with a simple way on Kubernetes to deploy your models, a very simple definition. And then we'll take care of the rest in terms of actually giving you the endpoints, HTTP, gRPC soon, the ability to scale to 0, so you're not using infrastructure costs if there's no request coming in. The ability to handle GPU autoscaling, so scale up on demand and manage that for GPUs as well. Safe rollouts, so handling canaries and managing all that. Optimized serving containers for the particular types of models that we handle. You can also have custom models. I haven't gone into that today, so you can actually define your own model in a custom container rather than the standard ones that we have for different types, like TensorFlow there on the left. We'll handle the inputs for the tracing and metrics as well, which I also haven't gone into in depth today, but that's managed as part of what we're doing in KFServing. So I've discussed KFServing, and now I want to go into, okay, you've got your model out, you're using KFServing, but is that the end of the game? Well, obviously not. There's things, as we mentioned earlier in the introduction that you need to do. So what are those things you need to do? Well, in machine learning, there's probably 4 big areas that you probably want to concentrate on once you've got your model into production. One is performance. So that will be, understanding, because obviously your model is giving a prediction about the world. And at some point, in many cases, you'll be understanding whether that prediction is correct or not. And you can send back feedback to your model to say, okay, you got it right, you got it wrong. And that'd be great to show on metrics. Also, in some more advanced cases, you can use that feedback to actually change how the model is behaving in real time, saying, okay, you're getting these wrong, can you change things? And that's one area, performance. The other area is just metrics, the core metrics that was mentioned. So the actual data distribution metrics, which are quite different and more complex in the machine learning world than more traditional applications. Then the other aspects, which are more really focused on ML, like drift and outliers. So when do I need to retrain my model? Is the input distribution to my model actually different to what it was trained on? So I need to tell the data science team that they need to really train on the latest data, or are there outliers coming in? And are there explanations, and can I understand how my model is behaving? And I'm going to focus quickly on these 2 aspects in the talk today, drift and outliers and explanations. So machine learning explanations. So why do you need to explain your model? Well, one is to really build trust that your model is doing what's expected, to reduce understanding and accountability, so you can understand and show off to auditors how your model is behaving. And also at the early stage of development, you can use explanations to sort of troubleshoot and understand, is there bias in my model, by sending in particular requests and seeing how the model is behaving, why it's giving the results it's doing. And also, if you're using some of the very advanced pre-trained models that exist down there, you can also use explanations to understand how they're behaving. You might not have trained this model, but you need to really understand how it's behaving and to take those understandings. So that's one reason. The other reason, as I think I've mentioned earlier, is the actual regulation, especially with GDPR and other things. You really need to understand, give understanding back to people using automated systems why the automated system is giving the result it is. And so if you have a model, say a deep neural network, it's going to be quite hard to give that back. So you need to have extra technology. So you can use the latest models like deep neural networks, but also have the ability to actually get explanations. So it really gives you the ability to say, is the model doing what I think it's doing? And, you can give that back to both auditors and customers and help you understand how the model is behaving. So the actual goal of explanations is quite a difficult area, because basically what you're trying to do is create a human interpretable understanding of why the model is giving a particular prediction, but it can't be, but at the same time, it can't be oversimplified. So obviously there is a trade-off, which is why there's no real silver bullet in this area, as we'll go on to show. And it's really a trade-off between the interpretability and raw fidelity. Obviously, you could just show the pure weights of the model. That would be the lowest level, but that's not going to be human interpretable. Or you could create a very simplistic explanation, but then is that really going to be true? So it's a very difficult area. It's a current research area, and there's many different ways of solving it. So we have a open source library called Alibi Explain, which you can find in that link, that tries to provide state-of-the-art production-ready implementations for different types of techniques for explanations. So one question might be, why are there different techniques? And there's various reasons for that. There really is no silver bullet. So the explanation technique, actual person who's going to be using the explanation, it could be a data scientist, it could be an auditor, it could be the actual customer-facing person who's just using your application. And also, it will depend on the type of input data for your model. So certain techniques work better on certain types of input data, whether it's your model is a classification model, whether it's a regression model. What is the input data for your model? Is it a tabular input? Is it text input, image data? And does it have categorical data? And do I have access to the training data? So all these things need to be taken into account, and then you can choose one of the options we have in Alibi on the left, which give you different options. You might be using anchors, which may be more of a data science explanation technique, or you could be using counterfactuals, which are very useful in other areas, maybe more customer facing in that respect, easier for someone who's non-technical to understand the explanation. So just to quickly go into how, in anchors the case, one of the explanation techniques, it works. So you have like an image, which you've got a prediction back, saying it's a cat, and you want to say, okay, why did the model say this is a classification model for images, say it was a cat? So basically you send the same input to the explainer. And basically, as this explainer is a black box explainer, it's going to be calling out the model many times by changing that image slightly. It's the core technique many explanation techniques use, changing it slightly and seeing how the model responds. And from that aspects. So it'll be changing different parts of the image, maybe cutting out the image and sending parts of the image to the model and seeing how it responds. And from that, it can tie it down to say, okay, for this image, it was this part of the actual image that the model was using to say, in this case, it was a Persian cat. And that gives you an understanding of how the model is focusing on certain aspects. And you can look at other types of cat images or other aspects to really understand how it's behaving. So that ties in, and it's very easy to tie in explanations to KFServing. You can just add a component there, as we've shown earlier, and add these explanations from Alibi in, so you can use them. Here's an example, 2 examples. So you just tie in those here. So we've shown that earlier before to really make it easy to use. There's demos, and so if we'll have access, I'll give access to the slides. So you can use a couple of demos here to get going with KFServing and explanations. One for the income prediction. Actually, in our demo, we'll show this one after in this side demo afterwards, and also a movie classification one, both on the open source for KFServing. So with these slides, you'll be able to go to those links. So the other one I just want to quickly focus on before the end of the talk is ML monitoring. So first, things like outlier detection. Well, why am I interested in outlier detection? The main thing is that models fail to generalize well on out of distribution data. So they can be overconfident and they're going to give the wrong, likely bad responses. So you don't want to make predictions if you've got a live machine learning model on outlier data. If you're doing that, things are going to go badly wrong. So really, you need to have an outlier detector as part of your whole what you're putting out into production, so that when you get those outliers, you know that's happening. But again, I mean, I suppose I've said this various times and it's appeared that there's no easy solution. These are very difficult areas, and that's probably why it makes MLOps so challenging. But there's various techniques of trying to understand this. And obviously, the fact that there are outliers means you probably don't have many of them in the actual data you train your model on. So it's like a bit of a chicken and egg thing. How do you spot them if you've never seen them before? So we do have an open source library again. You can find called Alibi Detect, which is looking at different areas of this aspect of actually sort of monitoring your models in production. One is outlier detection, and again, it's the same aspect. Depending on the actual model you have, there's a wide range of techniques we actually implement, depending on whether it's tabular data, image data, time series data, or text. Again, does it have categorical features? And then whether you want it to actually be online or not. Do you want the outlier detector to actually learn as it sees the data coming in? Or do you want to actually just train the data, train it on the original training data, so they can try to understand what's outliers with respect to the original training data? And also other aspects like feature level. Do you want to understand get outliers for particular features or the actual prediction as a whole? We also have other aspects for adversarial detection, more of a niche area, but obviously very key for things like driverless self-driving cars and stuff. That's obviously key there. And also drift detection, which I won't go into too much today, but again, that's obviously key. Again, you really need this if you're putting your model into production, because you need to know when do you need to retrain your model. Is the data that the model is seeing now as a whole not the same as what it was trained on? And if you don't know that, again, you'll be creating predictions which could be actually harming your business by giving bad predictions. So again, it's very easy to tie this into KFServing. Basically, KFServing has a component that allows you to log the outputs that the model is seeing. These are created asynchronously and produces cloud events in the Kubernetes world, which is basically just a type of protocol that describes a payload. And these can be sent to Knative that we use, obviously, as part of KFServing. And then you can add in the components such as the outlier detectors from Alibi Detect or the drift detectors. So when the events come in, the requests or responses that the model's been seeing asynchronously, so not harming your model latency, they can be processed by outlier detectors, adversarial detectors, etc., and actually managed, and then you can send off the alerts whether there's outliers. And there's examples, again, in the KFServing docs for both outlier detection. We've got the link here. There's also one for drift detection in the docs, just showing how you can tie that in. So really giving you more of the full system that you want. Prediction model running at scale, serverless, but with drift detection, outlier detection together. So great. So I'm close to the end of the talk now. The roadmap for KFServing, we're still, as I say, it's still moving forward with state-of-the-art stuff. One of the things we're looking at is multi-model servers. So I mean, it's great to serve individual servers, but what happens if you've got thousands of models? You don't want 1,000 servers. You want servers to probably share those models, so you can save again on infrastructure costs. And we're looking at that some of the work we're doing. And then we're looking at a more general cross-industry protocol for machine learning prediction, which is being supported by the people there. Like NVIDIA, KFServing, Seldon ourselves, and also Facebook TorchServe. So one general protocol that can be used across all these different inference servers and solutions to actually provide a solution. So yes, just a quick shout out to our Seldon deploy demonstration, where we'll be going into a deeper depth on how we tie these technologies together in our enterprise solution. And we can go into that in the side session that we're running. We'll be very welcome to have people there. So yeah, so I mean, that's a quick illustration of what you'll be seeing in the demo of our UI and how you can use it. And so I think I'm hitting the time now. So I'll stop there and leave it open to questions.
Round of applause. Thanks for that. And there are actually a few questions in the platform. And if people do have questions, please do open up Clive's session, and it's in the right there under live discussion questions. So from the top, we have a question from Tim Green, who asks, why is a service mesh like Istio useful in a cluster running inference tasks?
These stacks are built one on top of the other. So Knative is using Istio to actually manage the canary aspects, but you can also use Istio to manage some of the security aspects for you. So adding SSL endpoints automatically to your cluster, and you can manage some of the actual authorization of how the microservices fit together. It has to be said that Istio is quite a powerful and complex solution. So there are alternatives to that. And actually, also what we're doing in KFServing is looking to make Istio an optional component. So, so I say it's quite a sort of solution. You need to decide whether it's good for you or not, Istio and stuff. But it has some great aspects to it.
Okay, thanks, Clive. And actually, there's a natural follow-on to that. And I think this was in the light of the example there you showed with KFServing. The question from Phil is, from a user perspective, a single YAML is indeed simple, but could you comment on the operational burden of this increasing stack? And I think that's in the light of adding Knative and Istio into the stack as well.
Yeah, I mean, definitely. I mean, the stack is quite extensive, and some of these projects are still maturing. So that's why we're working on both projects and seeing how Seldon Core and KFServing to see Seldon Core, we have a more sort of traditional stack, which is more mature, which doesn't use Knative or aspects, so you have that options. So yeah, I think as these stacks mature, you have to decide whether they're good for your organization, the benefits they give. So serverless obviously gives a lot of benefit. And as Knative matures, I think it is a valuable aspect. I think machine learning in terms of serverless, given the costs of having GPUs, etc., running your cluster, you really don't want to be using them if there's not enough requests coming into your inference service. If you want to be managing thousands of different inference services, which might have different traffic patterns. So I think some of the burden of the stacks certainly is something that takes into account, but with ideas like GitOps, which hopefully will be talked about more today, you can simplify those and having interfaces into those at a higher level. So having a very simple interface to say the custom resources on Kubernetes that build the actual underlying YAML for you, so your data scientists can focus just on what's important to them. I think that's key, definitely, as well.
Okay, so it's keeping sort of clear role separation in some sense. There's a question here from Warren who asks, what is the difference between KFServing and Seldon? I think that's an interesting question. Can you sort of tease out that difference?
Yes, we work on both projects. They share a lot of technologies, like they both have Alibi in both components. They share some things like logging and aspects. So Seldon is built on a non-serverless stack. So it's built on more mature aspects of the sort of Kubernetes stacks. We don't use Knative. Whereas KFServing is slightly earlier in terms of its maturity, built on Knative. So an organization needs to decide whether they want to use serverless or not. And that could be a choice between Seldon Core and KFServing. But actually in the future, we're trying to see how we can actually combine the projects to have like a unified project. But it's still a work in progress. And hopefully we'll see where we go with that, because we work on both projects. And as I say, they do share a lot of similarities. So we're seeing if there's ways we can join these projects together in the future. So that's like, we'll see where we go with that.
Okay. And one thing occurred to me as I was listening to your talk around the GPU metrics, and I was wondering whether the metrics are actually highly dependent on the underlying hardware, or whether you've been able to successfully abstract into a set of metrics which don't, to some degree, are harmonized between the different underlying hardware.
Well, yeah, I think that's one of the challenges, and that's one of the nice solutions to Knative is that you got GPUs, you got TPUs. Yes, you got different types of GPUs that coming out from different providers. They all provide slightly different metrics of how they're actually running. And so actually what you do want is a solution that abstracts over that. So I think that's one of the great things that Knative provides, that KFServing builds on, is that you don't have to worry about those metrics. It's just looking at a much higher level thing of how many requests are waiting to be served and deciding on autoscaling based on that. So you can get away from that. So you can still use these great underlying hardware components, but not have to worry about as you say, the very complex and heterogeneous metrics that they expose.
Okay, brilliant. And so the Seldon workshop is going to be at 10:30
Yep.
today, and that's with yourself, is it, Clive?
That's with myself, and also Alejandro, who's our ML director, and so he'll be so demoing our Seldon Deploy enterprise platform, describing how it brings these actual technologies together and provides a unified interface, and how enterprises are using it at scale to really use Seldon and the components I've discussed today, so KFServing, Seldon Core, Alibi. Yeah.
Okay, great. So that's happening at 10:30, and if people want to access that, that's going to be available through a link that's on the workshop itself in the conference platform. So thanks so much for joining us today, Clive. That was really, really useful, and to hear about your product. And I'm sure if people want to reach out to you, they can either reach out to you on the platform or email you directly.
Yeah, absolutely. It'd be great to have further discussions.
Okay, great. Thanks, Clive.